Today's lesson is part 2 of direct linear variation. I'm going to do some 3 questions. Now, most of the questions, all of them actually, are from the actual exercise. Okay, before I start, I just want to show you something that I think last lesson I briefly showed you the comparison, if you like, the linear modeling and linear variation. So linear modeling is the standard form that we normally do for an equation, the straight line equation, y equals mx plus c. And m is a gradient, c is a y-intercept. In here, we use it as a vertical intercept. Now, linear variation is the starting point is a 0, 0 origin. So the c, the vertical intercept, is also 0. Okay, therefore we don't have y-intercept on this one. So the simple formula for linear variation is just y equals kx, and k being the gradient. Okay, one linear modeling has 2 terms, mx plus c, whereas a linear variation just got 1 term. That's all. Therefore, because it's a 1 less term in a linear variation, there'll be a 1 less steps to do, right? Because we don't have to find the c. So step 1, both of them, step 1 is finding the gradient. Okay, for linear modeling, we have to find the m. Linear variation, we have to find the k. But because we got 2 unknown, easier to remember is if we got 2 unknown, you got 2 points to work with for a gradient. Whereas you just got 1 unknown, which is k, it's easy to work with 1 point. Okay, because that's just perfect number to work with 1 point. And when you work with 2 points, obviously you've got to decide which one's going to be my first point and which one is my second point. Why is it important? First point coordinates, we're going to name it x1, y1, and the second point we're going to name it x2, y2. And that's going to be very important factor for gradient, because gradient is rise over run, which means rise is a change in y's and then run is a change in x. So when we do some changing stuff, we do takeaway. And we got to do that with first point and second point. That's why it's important. Now, step 2 is substitute that what we got, the gradient from the step 1 for the linear modeling. And then you substitute another point. Of course, you can use the same point as the step 1, A and B, or completely different point if you have them. And then substitute into y equals mx plus c to find c. Whereas a linear variation, step 2, you just rewrite straight into it because we found the k. We don't need to do anything else. So y equals kx, you just put the k in, and that is your completed equation. And you just use that equation to solve any problems for linear variation. Whereas a linear modeling, after you find the c, then step 3, you rewrite the equation, which is going to be the completed equation, and then use that equation to solve the linear modeling problems. Okay, so that's what it was. And okay, question 1. All right, so question 1 says the graph illustrates the fact that the mass of fuel an airplane requires varies, changes directly. I see what's happening here, directly. So what does that mean, directly? It is direct variation. I can see the little x's and y's and things here. So that's my x, that's my y. Easier for me to indicate, to see. Okay, so part A, form a variation equation. Okay, so you just have to find the formula. That's what that is. Okay. In here, it's f equals something, isn't it? Because that's our y here. Okay, the f is our y. then D is our X. Now, because it's a very directly, it means our direct variation. So it's going to be K and X is here, D. So I can see straight away that the general form, the formula for this equation is F equals KD. Okay, and then it says using a point. I can just pick any point here, but I don't want to put the point that it's in between two integers, you know, like point something decimal. So what I'm going to choose, that is a nice one. This one looks good. What else? A point, any point on the graph to find the constant of variation. Okay, constant. So, you know, K is our constant, so you have to find. So let's have a look. So F in terms of D, isn't it? F of D. Like normally it's F of X, but here X is D, so I'm going to write as F of D. K, D at the point that we are using is 250 and 600. So be very careful when you have to choose a point from the graph. So make sure you get the clear one. So I'm going to put this is my D, that's my F. So my F is 600. My K, I don't know, they have to find. D is 250. So I'll go 250K equals 600. I'm going to divide it by 250 on both sides. I will get K equals, get 600 over 250, which is 2.4. Now, that's just the K. Okay, that's not the actual equation, is it? So my equation, because the question says form a variation equation. So I'm going to go F equals 2.4 D. That's my equation. Next one. Okay, it says use the equation. Excellent, excellent. So we can just use that equation here, 2.4D. Lovely. To calculate the amount of fuel, so we're going to have to find the F. We don't know. Required to fly, the distance is 3,250 kilometers. Okay, so in here, solution, I'm going to go F equals 2.4D and find F when D equals 3250. So I'm going to go F equals 2.4 times 3250, 3,250. Put that in your calculator, you get 7,800 kilograms. Wow, that's a lot, isn't it? 7,800 kilograms, my goodness. Any questions so far? It's all straightforward?
No, I have a question, Miss.
Yes, go ahead.
Just one thing I was confused about. Could you scroll up 1 second?
Here, up to here?
If F equals 2.4D, because that's because they traveled 250 kilometers.
Yeah.
If that's not 1 kilometer, then why are we timesing that by the 3,000 thing? Because that wouldn't that.
Okay.
Does that make sense? I don't know. Maybe I'm just a bit confused.
No. I just have to get a clear idea what your question is first. Okay, sorry. So you're asking me why are we times by 2.4?
Yeah, if that's not 1 kilometer.
General formula is not about just 1 kilometers. It is every 1 kilometer distance, you need a 2.4 kilograms of fuel.
Oh, okay. That's what I was thinking. Okay, yeah, that makes sense. Right.
So we're going to the next question now. A speed expressed in kilometers per hour is directly proportional. Lovely. I like that wording here. That just automatically indicates that this is going to be direct variation. Okay, so like y equals kx. So, and to the same speed expressed in miles per hour. Okay, so this one has x and y for us already. Excellent. So we don't have to think about differently. Okay, so automatically I am just going to say y equals kx. That's what it is because it's a directly proportional to. So that just gives me idea that it is direct variation question. So my equation, the standard form is y equals kx. Now, part A, it says find the equation. Y equals kx. So we need to find the k, don't we? And at any point you like. My favorite will be the first one, 30 and 48. But having said that, you can go with the 36 and 57.6. Okay, it doesn't really matter. It'll be the same because it's a linear. Okay, so this is my x, this is y. I don't really have to think about this one because it's x and y already. 48 equals k, I don't know, x is 30. So I'll go 30k equals 48, and I'm going to divide it by 30 on both sides. It'll be 48 divided by 30. That'll just give me 1.6. Now, that's not my answer. Okay, answer is the equation. So I need to put it in the equation for y equals 1.6x. Again, this means every 1x, you'll get 1.6y. Now, we need to convert. Okay, so let's have a look at this one. It says 60 miles to kilometers per hour. Miles was x. So x equals 60. And then y is the kilometer per hour, and we don't know. That's what we have to find. Formula was y equals 1.6x, and x is 60, and we need to find y. So I'm going to put y equals 1.6 times 60. So if I do that, I will get 96. Be careful what you write for your unit, kilometers per hour. Next one, let's have a look. Convert meaning change. Now that kilometers per hour was our y. Y equals 120 kilometers per hour, and convert that into miles per hour, which we don't know. So to convert it, we're going to use this formula that we found, 1.6x. And we don't know what x is, but we got y equals 120. So I'm going to substitute in that. 120 equals 1.6x. And I'm going to move 1.6x on the left, 20. And then I'm going to divide it by 1.6 on both sides. My x will become 75. Now be careful with your units. We're looking for miles per hour. So that's what we got. Okay. Okay, so last question here. Let's have a look. All right. At 3:30 p.m. one day, the shadows of objects of different heights were measured, then graphed. Find the equation of the line. Okay, so this one was given to us, this graph. How can I tell this is direct variation? Because from the question, it doesn't say directly proportional or directly change or anything like that. But, guys, it's here. It starts from 0, 0, doesn't it? That just indicates it is a direct variation. It's roughly y equals kx. Okay, now my x is h, my y is S. So I need to change this one. Big S equals, which is a shadow, because of K, X as a H. Okay, now I need to find the equation using a point, 1 point. A lovely thing is that we already got it there, so we don't have to look for it. If it didn't give it to us, I might use this. So that would be like a 150 here and 200. Okay, so now I'm going to find K at 250, 325. So that's my H, that's my S. Now, I think it's a good idea if you can just indicate which coordinate is what. Okay, don't just think it's X and Y, because it's not X and Y anymore. But because we were so well trained with the X and Y, you might get confused. So I think it's a good idea for you to indicate these things. Which one is my H, which one is my S. So 325 equals K times 250. So I'm going to move 250K equals 325. And I'm going to divide it by 250 on both sides. That'll give me 1.3. So my equation is S, not Y, S 1.3 H. Puppy, calculate the length. Length of the shadow, that's S. We don't know. The lamppost height is 244 centimeters. Okay, so the formula was S equals 1.3 H. And we need to find the S when H was 244. Okay, so I'm just going to substitute in. S, I don't know. 1.3 times H is 244. Now put all that in your calculator. It'll be 317.2. Don't forget the unit, centimeters. Okay, so that's what we're going to get. Okay, the last one. What is the height of a letterbox? So that is H. We don't know. It's a good idea to put which part is it, like representing S or H. What? And special condition here is correct to the nearest centimeter. Be very careful about that. After you've done a wonderful job and you didn't write it to the nearest centimeter, you won't get full marks, okay? Now here, the shadow, the length S is 120 centimeters. Okay, so the formula was S equals 1.3 H. H we don't know. S was 120, so 120 equals 1.3 H, and I'm going to put 1.3 on my left, 120, and divided by 1.3 on both sides. H will be 120 divided by 1.3, which will be 92.30 ... But we want that to be to the nearest centimeter, so it'll be 92 centimeters to the nearest centimeter. All right, well, that's all for today's lesson. Well done, guys.